In this video, we'll be treating how to resolve a vector like the one you are seeing here. It's actually not a big deal. It's a very simple thing. So look at this vector. Let me show you properly. Okay. So this is it here. Alright. So it's actually not a big deal to resolve a vector like this. And the goal of it is, don't forget when you are resolving vector, so you want to get the resultant and the direction of the resultant. Now look at, let me show you something. So look at here. This is the resultant, R. This is where the resultant is. And this is the direction. So when you're talking of direction of the resultant, you are talking of the angle the resultant is making with the x-axis. So that's that. Alright, let me bring it back to its normal position. Okay, so we can proceed. Now, the first thing you should do when you are resolving a vector like this is to separate it into the horizontal and vertical component. So x component and y component. Alright, so now let me quickly show you the angles more so that you get to see how it is. Now look at the 10 Newton. Look at the 10 Newton angle. So the 10 Newton, it is inclined at angle 30 degree to the horizontal. So that is telling you that it is the x-axis that actually has the angle. So look at the 15 Newton, inclined at angle 60 degree to the horizontal. So you understand, that's telling you that it is the horizontal axis that has the angle. So you understand. So the same thing, 12 Newton, inclined at 40 degree to the horizontal. So it is the horizontal axis that has the angle too. So you understand. So that's how that works. So you can see. So alright. Now, to do something like this, the first thing you do is to separate them into x and y components. Yes, separate them x component, y component. Then you start. Now, this is the deal. Anyone, for example, now I mentioned something that the angles belong to the x-axis. So when you are quoting for your x components, so for example, let's start with 10. So let's start with 10. So when we are quoting for our s components, that means we will say 10 cos 30 degree. We are using cos because the angle belongs to our x-axis. You understand? So you quote as 10 cos 30 degree. And also take note that to the right here is the positive x-axis, right to the left here is the negative x-axis. So you understand. So up here is the positive y-axis and down here is the negative y-axis. So you have to put that into consideration while bringing them out so that there will be no mistake. So we want to quote it for y-axis. So we want to behave as if so now we've quoted for x-axis. So that's we are when we resolve to the x-axis, we have 10 cos 30 degrees as if this 10 Newton here, this 10 Newton here is coming down here. You understand? It's coming down to this point. You understand? So you quote it as 10 cos 30 degree. So that's that. So now if you want to quote it for y-axis, you don't need to worry yourself. So you just quote it as 10 sine 30 degree. Can you see? So here is it's 10 sine 30 degree. So that one done. So now the next one is let me make it proper now. Okay. So now the next one here is 12 Newton. If you want to quote it, since it is the x-axis that is having the angle, so we quote it as 12 cos 40 degree. Yes, you understand now. So now, but the reason why it is minus is that we are dealing with something at the left hand side of the x-axis. You understand? This is the x-axis, left, the one at the left hand side, so it's negative as I said earlier. So that's why we have to put minus at the front of our 12 here. So and you can see the final answer also carries minus. So that's that. So now for the y-axis, you don't have to trouble yourself. You quote it as 12, just put sine 40 degree. Now why are we not putting minus in front of our 12 here, and we put it for in front of our 12 x-axis? Now the reason is not far-fetched. The reason is that look at this 12 sine 40. So it's as if this 12 Newton is coming here. You understand? So you will agree with me that this is the positive y-axis, so we don't have to put minus here. You understand? So it has to remain plus. So that's that. So the same thing with 15 cos 60 degree. 15 cos 60 degree. So you understand, 15 cos 60 degree. So yes, so you can see 15 here. So if we are to resolve it as if it's coming here, you understand. So that will be cos 60 degree. So you understand, it's not carrying negative because this is the positive direction of the x-axis, this side. You understand? So that's why. So you have to take note of that when you mix it at the point of the add positive and negative. So you have to be careful at that point. So that's where you can make mistake and you will not get the rest of the answer. All right.